My name is Dave Almeida. I'm a current PhD student in the University of Maine Spatial Information Science and Engineering Department. My research mainly concerns new approaches towards interacting with wireless sensor networks, something that's proven surprisingly difficult in practice. Specifically, I'm working in the area of macro programming, which, unlike writing spreadsheet macros, which is sort of what it sounds like, actually has to do with models of programming the network as a whole, putting a higher level model over the network and programming that model rather than a node level view. In other words, writing specific programs for the little nodes and hoping those collectively achieve some aim. Tag and TinyDB shown here was really one of the first large successful approaches to macro programming. It actually implements a model that is that of an SQL database. Some people consider this a sensor database management system. There are a lot of ways to slice and dice what you're going to call it, but effectively it's still presenting a higher level model in view for a user to interact with using that higher level query language rather than needing to write node level programs. So many do consider it to be in the vein of macro programming approaches. For my research, I'm considering another well-known data abstraction for sensor networks, that of a geographic information system. The conceptual model of a GIS is basically that of a collection of georeferenced layers, and layers are a fairly representation agnostic abstraction that also tends to be very flexible. And of course there's built-in functionality to deal with spatial data, as well as an existing query language that's widely known, often called map algebra, which tends to deal with field-based data. One thing to note is that a lot of environmental monitoring data, geoscience data, environmental science data, ecology data, etc., eventually finds its way into a GIS. So this might make it an interesting area to explore for sensor networks. This slide shows a representation of our approach, showing the embedded form of the GIS in the upper left corner. Below that is the conceptual model of the layers, conceptual data model, and also conceptual model of the results. What we can see above that is the active map algebra query, which is a compressed subset of map algebra. But here we're doing a neighborhood operation, basically finding the deviance in a neighborhood, which is really something that probably would not be possible with an SQL representation. So we see some benefit from adopting this model right away. Now we're also looking at a sensor data stream here. These are all sensors that were attached to a given node. We can see that there's quite a bit of noise here. So another thing that we're bearing in mind with this research looking forward is model-based data acquisition to help deal with that, in addition to data storage networks. Also, I'd like to make all the following acknowledgements listed here. Thank you very much.